So thank you very much for the introduction. And we've heard some very inspiring talks to date this morning about the promise of 5G, what 5G is going to be when it's delivered and how we're going to deliver it. I want to turn attention to and quite an important piece of this, which is the validation of 5G and how this goes beyond the traditional testing use cases that we've seen in older technologies. And then the reasons for this. And I'm delighted to be sharing the stage with Dritan this morning, because Dritan is spearheading efforts in the UK to foster the innovation that we need to bring different entities together to deliver the use cases and prove them out, show that they're fit for purpose and that they can actually transform the society in the way that we heard earlier from Telefonica. We're going to cover some different areas on this and how we're going to, why we test, what we test, and what are the challenges that we face and how we overcome that. So with that, I'd like to hand the floor to Dritan to start us off.
Thank you very much, Chris, and Annie for the introduction, and good morning, everyone. It's a pleasure to be with you today. And as Chris said, for us, it's quite important to understand the role of the 5G and how we build more broadly than the 5G itself, and looking forward to 6G infrastructures that are fit for purpose in a very, very highly changing environment. We live in a highly interconnected world where literally digital connectivity has transformed already the way we live, play, travel, and work. But in this particular world, the digital world is based on application and services that people experience directly. But there is very, very little understanding of the invisible interconnected digital infrastructure that is underpinning all of this. And if 5G could be lauded for one thing and one thing only, is that through the push that 5G and the mobile industry overall created towards the vertical industries, it exposed for the first time that particular fact that this digital infrastructure is transforming itself, it's becoming more flexible, and it cannot be considered fixed and taken for granted. So it is a particular transformation that has happened in the last decades, where the telecommunication fabric that underpins all of this interconnectivity has started to shift for the demand side from a position of in a good way, but bluntly put, who cares, to why does it matter, and why does it matter in my case, as you heard from the Telenor talk that you had before. For me, and by way of introduction, is why we, both Chris and I, find ourselves in giving this talk today. It's primarily because I work for Digital Catapult, which is a leading advanced digital technologies innovation center in the UK, which has an extremely strong technical capability in order to work at the interface between the technology fabric and the people that take advantage from the technology on the digital services space innovation. We work across several digital technologies, 5G, IoT, AI, and immersive. And as I said, in 5G in particular, we have been looking in the past 5 years, working with people, building use cases and projects where we try to shift people from what we call the curious and shifting them from the who cares attitude to why does the infrastructure matters? What does it make it meaningful and purposeful for you? And in that space, for example, we are doing currently a 5G Factory of the Future project, in which we are working with an advanced orchestrated and sliceable 5G network that Digital Catapult is providing, integrated with an IBM Edge compute solution, working with BAE systems to support delivery of real-time production monitoring with less than 10 milliseconds reaction time, response time, with immersive co-working or with chain of custody supply chain automation use cases. And in the same way in other industries, in creative industries and others. But whilst we have been working in this kind of adoption demand generation space, this is incomplete without a clear understanding, without looking at the other side of that elastic interface on the innovation on the technology supply side and the technology development. And Chris? And in that space, as we said before, we are effectively looking that open and interoperable disaggregated systems are a firm direction of travel for the networks. And in this space, the challenges of the open and disaggregated systems that will continue to be the norm for the next decade and beyond are exemplified by Open RAN. So we are picking up on Open RAN as a particular example of the overall direction of travel on infrastructure, where we are building a distributed system over general purpose compute platforms, whilst requiring to meet some very stringent performance requirements. And these requirements are more stringent the closer you get to the radio area interface. And some of the elements that we can pick up here is increased complexity, multiple open interfaces where previously optimization and cross-working between this was done in a closed vendor-based systems, where people were providing OEM or white boxes even within those closed vendor systems. The interoperability between vendors becomes critical. Manageability and operational support for deployment is one of the biggest hurdles, but also looking at performance optimization and security. How will you be able to do this with third-party service provisioning? And in this space, we have picked up in particular for interoperability and interworking as a technical lever to be able to support innovation space. Chris? This is where we effectively go into what we have today, which is the Sonic Labs. Sonic Labs is a joint program of work between Digital Catapult and the UK regulator, Ofcom, to foster the emergence of mid-term new solutions in the telecom supply chain in the UK. And we are focusing in particularly multi-vendor, open, disaggregated, and software-centric network products, starting with Open RANs. The labs are currently live and operational since June 2021, where we have built 3 actively functional end-to-end operational RAN chains, Open RAN chains, mixing and matching products from 8 different vendors like Mavenir, Acceleran, Benetel, Fluido, FNet, Radisys, and others. It is funded, this initiative is funded by the UK government's Department for Digital Culture, Media and Sport, to specifically look at how to support the innovation in the pipeline, and with 3 basic objectives. One is to kind of look under the hood on the reality of Open RAN and the successive relevant open network technologies, to try to make a better connection between policy decisions and the technology roadmaps as developed by the industry, and also to enable the government and the regulator to have a good understanding of the technology readiness and the direction of travel there, whilst it is addressing the challenges that are listed on the 4 blocks on the left-hand side of the slide, like the disaggregation, the fragmentation across different vendors, cloudification, and the concentration of the solutions in a very small number of multiple vendors. So what does this Sonic look like? Next slide, Chris. We are focusing primarily on the interoperability, because as we were focusing, we looked further ahead. A major challenge in the Open RAN space and in general in disaggregated networks is the manageability of the network, and in particular, the ability or the sufficiency of the interfaces based on specifications and later on in standards to support new third-party optimization apps and services, as well as the operational interfaces on the user plane and the control planes themselves, which can simplify operations, can improve performance, and can drive the costs down. And one of the crucial lessons that we learned whilst we have run this program for the last year, and as we look forward to be running it for the next 5 years, is the importance of testing, even in early development stages of the products, in what we will call technology readiness levels 5 to 7, so pre-mobile network operator testing, to effectively say, looking at the importance of end-to-end testing at that part, where typically in today's terms, most of the testing at that stage of the product development is done with things working on the next hop interface, either northbound or southbound interfaces. And the next biggest thing, and it will come as no surprise to many of you, was the need to be able to support a flexible, innovative, up-to-date and end-to-end, and in particular automated test and measurement platform, which will allow us to support companies to understand earlier in their product development stage where their primary challenges are. So looking at that, we have effectively looked at, next slide, Chris, at a very large scale kind of testing platform. It is an overloaded slide and the slides will be made available, but the primary thing that we wanted to say in this, it is the importance to shift and to be able to provide a testing ability, even in earlier stage development product phases of both lab-based testing as well as field testing in an end-to-end particular system. In Sonic Labs, we will be deploying a test network in the lab where we have it today, but we also provide access to a public access indoor and a public access outdoor environment. And it is particularly in order to understand how the equipment, even in development stages, performs, and where implementation decisions that companies will continue to make during those early development stages will exhibit potential operational challenges, or potential operational faults, or potential requirement for realignment in specification and in standardization space. So that particular balance between lab-based testing, which is expensive but not superbly expensive, to field-based testing, which usually is very expensive, but providing that support in earlier phases of the engagement with the innovation companies, is particularly important. And at that point, Chris, I hand over back to you.
Thank you very much, Dritan, for the insight there into what is happening with Digital Catapult and Sonic Labs. So I want to take a step back now and think about the talks we've heard from Dritan, from Telefonica, from Telenor, from Tim, and we're asking an awful lot. We're trying to transform our telecommunication networks with new technologies so we can deliver the new qualities of service. And this means that we're pushing technology to its limits. We're opening up new spectrum. We're using things like massive MIMO, heterogeneous networks, and we're disaggregating the networks into their components, and we're distributing those. And we need to have dynamic networks as well that are able to respond to changing demands on them. And they're also automated, so they're able to respond automatically. They don't need to be handheld. They don't need to be necessarily programmed to respond, but they can learn from how they operate, so that they can respond automatically. So we're all asking an awful lot here. So what do we test and how do we test? But before that, even, why do we test? Can we get away without testing? And ultimately, I think the answer is that 5G will have failed. The 5G project will have failed unless we can deliver these innovative use cases, the different verticals across commercial and retail verticals. If we can provide consumer services which are low latency, very rich experiences, and we can open up new verticals in industry to be addressed with 5G, that's what the service providers need in order to get revenue out of their networks, and to also achieve the societal goals that we set out to deliver with 5G. So we have our goals of the 5G network, and we have all this great new technology to play with to deliver it. So, but what do we care about? How do we build a system which is quite complicated and dynamic and has different components coming from different vendors? How do they interoperate together? They're learning, they're changing how they change over time, because they're enabled by artificial intelligence and machine learning. Well, we want to make sure that things interwork properly. If we've selected a particular set of solutions and we put them together, do they interwork? Do they operate well together? Do they deliver what we expect to? Do we get the radio performance we want? Do we get the capacity and the coverage that we expect, so that we're maximizing the return on investment that we've got for our spectral assets, as well as our other infrastructure assets? Are the applications performing well? And if we've got network slicing, are those slices performing well? Are they delivering what they need to, or are we going to be delivering paying because we're not meeting the service level agreements that we've got? And it's and can we do this without a massive capex investment? If we have to invest tremendously to do this, then that's going to push up the cost of these things and keep out the some of the use cases won't be cost effective. And then there's also OPEX considerations, and very pertinent now with COP26 happening in the UK, energy consumption. If we can do this with low energy, we heard earlier about this is very important for the operators themselves, but it's also important because of reputation. If you can be delivering your services with low energy, then that's something which is of interest to the consumers now. People are becoming more conscious of this. So it's, how do we test something which is so complicated, so diverse, so dynamic, coming from different vendors, and what do we care about in terms of measuring as we test these things? Now, I was really interested to hear the Telenor presentation just now because of the mention of digital twin, and I think the digital representation of networks is becoming more important, and it's becoming more important because it allows us to avoid the cost of going to a field environment to do testing, and it also enables us to sort of break the barriers between the different stages of the network life cycle. So if we can reproduce in the lab the environment we expect to see in the field, this becomes quite important, because it means that we can be more confident that as we select our components of our solutions, that they do work together in the way that we expect them to and want them to and need them to deliver the SLAs that they'll have to do in the field. And so representing that network becomes important, and representing the network in its in diverse forms. So if we want a service that's able to operate in different types of environments and respond well in all its complexity, so that the different components, particularly in the intelligence, are able to respond to different environments, then we want the ability to create different environments in that lab environment. And but we also sometimes want to make sure that we can represent a specific network. We've got a network that we're going to be deploying to, and we want to be able to, as much as we can, represent that in the lab to make sure that in the specific case, not just the general case, it's not just dynamic and able to respond to many different scenarios, but it's able to respond to the specific scenarios it will be experiencing in my network. Then we need to be able to reproduce those aspects, and we can think about this in many different layers of emulation and how we can bring the experience that we gain from the field back into the lab to enable the rich testing. And it's not just about the testing. It's not just about building confidence that we have a system that is able to respond to what it's going to experience out in the wild, but it's also about the before we deploy. Some of these components are going to be powered by machine learning, and if we can train them before we put them out into the wild, then that gives them a head start so they can hit the ground running and be operational from the word go. And as we see the automation and continuous integration, continuous delivery becoming more important with these cloud native networks, then having testing as part of that deployment chain becomes a possibility and will become more important, because we're protecting our key assets to deliver those SLAs on those slices. And then out in the field, there's even the digital twin, the emulation environments can have a role to play there, because we're making decisions out in the wilds. These intelligent applications, the intelligent machine learning driven applications are making decisions, and we need to make sure that they're able to make the right decisions. They're able to have a sandbox in which to operate to support their operations and ongoing training. And then just a thought on the standardization of the networks and what does the role of standardization play? Well, it's a direction of travel rather than a destination, and there's much work to be done. There's much work still to be done in 5G, and the industry starts to look towards 6G. And it's about making sure that as we disaggregate the network and we've got new components and new interfaces, that those are tested. They're able to be tested. We can check for inconsistencies. We can check for interoperability problems, and that they are robust as we deploy these multi-vendor components. The AI and ML, we're not just testing functional capability, but is the AI and ML delivering what it's intended to? Is it delivering the automation of the network, the optimization of the network in a reliable way, which isn't vulnerable to edge cases and emergent behavior, which we can experience when we put these intelligent agents together in new environments. And the industry needs to work holistically. We have 3GPP defining various geometries for testing, and those cover what 3GPP covers, but as we disaggregate into more components, the industry is responding to that in O-RAN Alliance, for example, defining those the test cases which go beyond the standard 3GPP geometries, so that we can deliver the testing for conformance, interoperability, performance load, and system testing that we need to. And with that, I'd like to hand back to Dritan for some conclusions.
It's what both Chris and I try to convey today is that understanding this particular developing landscape and looking at the Open RAN as an example of what is the direction of travel more broadly in telecommunication systems and networks, and looking at how the specifications, for example, in the O-RAN Alliance, and also the standards are developing very fast, and under a highly pressured market for 5G and looking beyond, it is clear that testing in general, and in particular end-to-end testing, is extremely important at an earlier stage on the product development. And that is primarily to support both new and existing companies to develop faster products with a higher certainty that those products will work in the market better, so that they can do optimizations for the deployment earlier on, so that they can do them deployment conditioning a bit more easily later, as companies journey in their development from an R&D phase into fully deployable products that can go to system integrators for private networks or mobile network operators at national level. Furthermore, and this is quite important because this is a shifting and fast evolving landscape, innovation within the test and measurement sector itself is particularly important. And multi-supplier test suites and test platforms are also crucial, both to support the innovation, but also to understand and manage better the risk of specification and standards fragmentation, as well as the cost of the companies at an earlier stage of the product development. And finally, we will operate in a test and measurement multi-vendor environment, as we are already in a multi-core, multi-RAN, and a multi-UE environment as we look forward. And this is a kind of a fixed direction of travel for us. Thank you very much.
Thank you for that, Dritan. Sorry, I almost forgot to unmute myself there. We have a question for you, please. I'm not sure whether you or Chris will take it, but that's up to you. What is the uptake of self-organizing network deployments among the cellular networks? And what are the key testing solutions specific to SON testing?
I can have a go at that one, Dritan.
Yes, please, Chris.
So I think it's going to be key to delivering on 5G to have the solutions which are at least inspired by SON concepts. And I showed a slide earlier with the RAN intelligent controller, both the centralized or the non-real-time and near real-time, and having intelligent agents or apps, as they're called, on that working together is going to be key to delivering optimal behavior in ordinary situations, and it's also going to be key to responding to adverse events, outages, congestion, those sorts of things. So I think it's going to be, the automation is key here. We can't deliver 5G without a way to automatically respond to these things, and we're seeing many organizations in the industry, different companies, like particularly some working with Dritan and Digital Catapult and Sonic Labs currently, and VIAVI and our other companies, as well as the service providers themselves, delivering that sort of capability inspired by SON. I mean, and in terms of the testing requirements for that, it's not just about the ability to test that an application on its own can deliver, for example, coverage and capacity optimization or intercell interference coordination. It's about testing that it can do that in multiple scenarios, and it can do that in conjunction with an ecosystem of a different RIC vendors and different applications also trying to do different objectives at the same time. So you need to be able to test that ability for it to work in an ecosystem, responding to different stimuli in different scenarios, and not have emergent behavior that is undesirable or be vulnerable to malicious attack, which when you have AI and ML is a consideration, because you can have attack from a distance.
Okay, well, Chris and Dritan, thank you very much indeed.
Thank you for having us.
Pleasure.